Hello, everybody. Virtual Hackalong European Time session 15. So we are happy to go with our friend from Holochain, almost active member. Some of them active, some of guys here today new. Warm welcome. So before starting, we promise to review questions from Holoport session. Is there any question unanswered on unclear topic from a Holoport that you would like to open?
I think also during the session, Jakub, I remember, or maybe other people asked for like a visual representation of the infrastructure, and that wasn't possible because of the very tight time. But if you want, we could give it a go right now, like get the draw.io and start trying to draw things, if that's useful to everybody.
I want to get Chaperone running, but I started looking at it, and all you got to do is, you know, like include one thing apparently, but it didn't look as simple as that.
Yeah, and honestly, I haven't tried it, but I don't think it's production ready in the sense that the API it's going to be a little rough and it's not going to be well documented because people are not using. So those issues, those first issues that you have, that's not going to be solved. But anyway, I'm up to do whatever people want. I'm offering to do the draw thing, but if that's useful.
Jim, would you like to bring the topic here, your experience, and we can see and we can push and continue? It means, would you like to bring it here as a content that we can start working on it maybe?
What's the question, Hidayat?
Because you started experiencing this, yes? Or you wanted to know anybody else experience or not? Did you do any experience?
I went to the GitHub, the link that Joel sent, and I saw that there's some JavaScript there, and I saw some instructions, a little bit on what to do with, you know, if you're running Node, and I'm not running Node. What I've got to do is I've got to get the right JavaScript up into my browser. So I got to get the right JavaScript downloaded to my server and put somewhere, and then I got to get it uploaded to my browser with all the right dependencies.
Okay, it means you didn't. Okay, let's see. I got your point. You couldn't finally do something.
I mean, I see what to do, but it struck me that that could take a number of hours, and if someone had done that before, that or if there were two people that wanted to do that and wanted to do it together, then it could be done in less hours. That's what it was striking me as.
Okay, anybody experience this topic, please bring it on the table. So, should we officially close the post question of the Holoport? Is there any remain topic, unfinished topic, open discussion that you believe you need to ask? Maybe you asked, the answer was not clear. Maybe you forgot to ask. Maybe new question. That's it. If you have it later, chat. Okay, so let's start today's session with Lily and Rezan. Go ahead.
Yeah.
Yes.
Sorry, I have just one question for Holo. Can I ask it?
Sure.
Yeah. So right, Yoel was saying that the source chain of a user or of an agent would have a redundancy of 5, right? But then so So if I understand it correctly, when we say redundancy in the Holochain setting, that means that every as long as there are more than 5 people on DHT, there will always be 5 people keeping that shard of DHT for you, or that copy of entry. Sorry, copy of entry, if that's the right way to say it. So if your source chain has a redundancy of 5 on Holo, I didn't quite get if that means that there will always be 5 hosting for your source chain, because like anyone could unplug their Holo port at any time, right? And will that automatically allow others to, or like assign, like something would assign other hosts to host your source chain, right? So then that's also the reason why I asked Yoel about the send and receive thing, if conductor will always be online on Holo, because if there's a redundancy factor of 5, then my assumption is that there will always be something online on the Holo side so that I could call something on my conductor. But then he told me that that's not the case, because Holoport can always be unplugged and whatnot, and you shouldn't expect that your conductor will always be online. So I'm a little bit confused there. I don't know which one is which. Yeah. So that's a question I have.
Yeah, absolutely. I think I don't know the full answer to that. I think there is a little confusion also because of the versioning. Like for Holo Alpha, it's only going to be one node holding your source chain, as I understood. But in the future, it's going to be 5 nodes. And I don't like the word redundancy. It's much more like a hard consensus, or I don't know. I don't like consensus as well, but it's not like the redundancy factor or redundancy of neighborhoods we have in a DHT normally, right? Because it's like these 5 nodes are the ones responsible for holding the whole of your source chain. And if one of them drops, the other must be available for you to connect, right? And continue working just like that. Mm-hmm. I'm a little confused as to the online offline as well, because yeah, I have the same question as you. If 5 nodes are going to be always holding your source chain or available for holding your source chain, why can't we assume that they are online? I don't know. That's a good question.
So we will find a way to answer the question. Don't worry. IoT, Lily and Rezon, please keep us updated about the thing that happened and how we can support you. Open the topic and please.
Okay, Razan, do you want to go or do you want me to go?
Yeah, you can start and
okay, and then I'll then you can, because you're doing most of the work. So yeah, we talked, Razan and I talked about kind of continuing from what we discussed a couple of weeks ago. And I think, when we talk about the hospital network, the patient network, the physicians and the hospital network, and then we talk about like actually writing down, documenting what are the requirements that's within the scope of what we want to do. And one of the things that I think that's really important to clarify here, when we talk about ratings, there are actually 2 kinds of ratings that we're talking about. One is a device-to-device type of rating, which is in the IoT space, when we talk about the trust management, most of it is talking about how you trust the information coming from the device, because that could be, there are different aspects of the data that you get, like or the speed or the different things that you rate on. So there's that level of rating, how much can you trust information coming from a certain device. And then there's the rating that we talked about in the last discussion, in the Hackalong session, where the patient rate the doctor's treatment. And so I think, we're going to focus, I think right now we're going to focus, when we talk about rating, how we're going to gather the information, calculate rating, share that. That's that focus in the context would be different from just the patient rating with the device reputation versus the patient reputation. And
So,
yep, and then the different use cases. That then there's a hospital setting, and if you want to be a little more abstract, then we have there. I think Razan has some other use case that you want to discuss as well. So Razan, do you want to take it from here? Thank you.
yes, thank you, Lee. Yes, I have make a simple presentation that explains these differences. So in case if we want to make the general skeleton or architecture that will be helpful for the IT environment. Just let me share you my screen. Okay.
Wait for Guillaume. Guillaume is going to give you the access.
You should be able to share.
Yeah, we can see it. Fantastic. Great.
Yeah.
Go ahead. Yes. Yes.
Yeah. This is the last model I have presented in a previous session. So we discussed, as Lily said, we have two parts of the application: the patient, which is the private network of the patient, and the trust rate. But what I'm thinking is there are many IT applications, and we can classify it into two categories before starting in this scenario. So this is the two scenario. First one, the machine-to-machine IoT, which is where the IoT devices we expect from him to be more intelligent and can interact with each other without any human interaction. So each IT device can interact with other and based on his own decision. Another part is the social IoT. So here in this part, we have a human that play a significant role in the community or the network. So as we mentioned in the previous example, we have doctors and patients. So the patient have its own IT devices and control these devices and share this information. So I think if we want to architect this two type of model, both of them will be different. So this is in the first one, there are many examples like the autonomous vehicles where the smart or driverless car can receive and interact with other cars without human interaction and can know about the status of the road if there are an accident or anything else. Also, we can imagine a robot in the industrial community, so it can directly interact with each other. Here is the trust level. If we want to place the trust level in this application, it will be very simple. So each device has its own trust level and can query about other IoT devices. Also, it can rate other IoT. In the second scenario, it will be more broad, and I think it will be more complex, where the human play a significant role in the system. So he can manage his own IT device, control these devices by shutting down or turn it off. Also share this data with the community, and the most important thing in this type of application, the privacy. So in this type of application, people need to have a privacy of their own data. But in the previous one, the privacy is not very important because we are in the open community, so each devices can interact with each other. So if you want to place the trust in this type of model, maybe it could have a different aspect. So in the scenario of patient and doctor, patient and doctor can evaluate or rate each other. Also, we can evaluate the doctor by the result of the IoT devices such as the diabetes or blood sugar smart devices. And in some cases, we also maybe we need to send data between IoT device to IoT. So here we will have three types of connection, such as human-to-human communication and exchanging data, human to machine or machine to machine. So this is the main differences. In the social IoT, we have an IoT devices plus the human, which is the owner of these devices. Privacy is very important in this type of application. On the other hand, the machine-to-machine, it's contain only IoT device. The main feature is important in this type of system is the dynamism, where this IoT can join and leave the network without any constraint. Also, we want to discuss the discovering the IoT. If we implement the Holochain application, how can these IoT devices will search about each other? Normally, the IoT can find each other through the wireless network or Bluetooth or NFC or each of these technologies. So in terms of the reliability or the trust, in the social IoT, we should consider both of the owner credibility and the quality also of the IoT devices, the service that IoT device is good or not, and its behavior. But in machine to machine, we focus only on the device itself. The last one is the example. In the social IoT, we have smart community, like smart home, healthcare community, and so on. On the other side, we have examples such as the smart industry and machine-to-machine communication. So this was the architecture that we discussed by the end of the previous meeting, where Hidayat and Gilam explained. So first, I don't remember who would suggest to make all IoT devices in one network. So in this diagram, we have these two IoT. Let's say this is the two robots want to interact with each other, and then send the direct message, which is the data, to the fog nodes, which is the powerful computer that stores the all IoT data. Then this fog node will send or bridge this data from the light or IoT network to the warehousing network, which is the biggest one. So in machine to machine, we can say this is two robots or two cars want to exchange just data or something like that. And in the second solution, which is the social IoT, here's the patient and doctor scenario. So here is the agents, the patient agent. Let's say his laptop that installed two applications, one for task management and one for his personal information. And here is the IoT devices. Each of them has a separate DHT. After the IoT send a direct message to to this patient, he can reach it to the biggest network, which is the data repository network. Then he can allow the doctor to access this data or revoke the permission and so on. So what I'm trying to say, in this different scenario, we can think about the different features that could implement in one of them, but doesn't make sense in other examples, such as the token. If we want to consider the token in machine to machine, we don't need to follow this pattern. And what else? Yes, here in separating the DHT of the IoT, if we make this thing in machine-to-machine communication, I think there will be a problem from exploring or finding other IoT, discovering other devices. So these things I want us to discuss it and see what is right or wrong.
It is done?
Yeah.
Okay, so before, okay, go ahead, no, go.
Yeah. This is the feature that I talk about, the capability token. Also the persona. I think in the first one, we didn't need, we discussed this previously with Lily, but I don't know here in which scenario we need the persona and which one we don't need it. We think here in the machine-to-machine, we can only identify the IoT by exchanging the key pairs, which is private and public key. And here in social IoT, we can use the persona or integrate them with the system.
Galen, you want to say something? I see your hands up.
Yeah, I have a question,
Yeah.
which is trying to understand the trust in the machine-machine use case. Which elements of IoT devices normally determine IoT device quality or the rating or trust of IoT? Like, I'm imagining maybe bandwidth, online time, those kinds of things, or is it totally different?
Yes, it could be. Also, it could be quality service, quality of the service, such as if this device complete the service to the end, but the reliability of this data, it's right or wrong. Also, the speed of retrieving data. We can think about many parameters. So
Right, and other kinds of IoT technologies and whatnot also use this kind of pattern?
sorry, can you clarify?
Yeah, so other IoT technologies also use this kind of trust ratings between devices?
Yes, there is, but it's centralized.
Yeah, interesting.
I had still the same question, but still I would like to continue. Can you redefine or explain again a little bit, what does it mean, trust between two devices? It means when I'm gonna connect to you, or you are giving me the data, the data is coming from you, it didn't manipulate, or you are a bad actor. Can you explain me more the trust between two machines?
Between two machines or trust in general?
No, trust between two machines in IoT. What does it mean? One machine is going to trust, what What does it mean, trust level between two machine to machine?
We need to identify the trust, because if these devices is the first time they interact with each other, so he can, if this device has a bad reputation or is in the blacklist, so we prevent interact with them. And according to the rate or point he gets or the trust level, I can, for example, give him more
Weight, right?
yeah.
In your rating. So so Razan, is that okay if I add a little bit to what you said?
Yeah, you can, of course.
Yeah. So yeah, correct me if I'm wrong. So because you definitely know the IoT space better than I do. So in IoT space, my understanding of the trust is like you calculate a rating based on different dimensions, different aspects of information you get. Whether they provide good service, which is depends on what service, the context of the service. What's like if you look at autonomous vehicles, there might be some IoT there. You look at smart home, it's all different, right? And depends on what are the criteria of of you giving a good rating for the specific IoT device that you're rating. It might be the speed of service, might be the quality of the service, whatever. And then I guess each device will rate the other device that it interacts with, and then there's some component, some system somewhere that might aggregate these ratings from different devices, and then maybe based on like the rating of each device, maybe their score, their information provided might be weighted to provide sort of an aggregated rating for different devices, and then that the rating information then can be shared to the different devices for however they made their decision. Is that accurate, Razan?
Yeah.
And also, can you give us one example, real example, how one machine can rate another machine?
Razan,
Okay, I don't have an exact example, but if we talk about the industrial community, so we need some machine interact with other. So each time this machine provide a service, if he provide a good quality service, his rate or trust level will be increased. And this will be assigned up from the customer that receive his trust. So as a machine, if we have different level of process, can we say, and we have the emergency or the sensitive process or different level, normal interaction or sensitive interaction or communication, and according the trust level of these devices, I can decide which I can receive or interact with this device or not.
Mm-hmm.
This makes sense?
Yeah. Go ahead.
I have it's a suggestion or a question, like both. If we think about Holohost in terms of a network of IoT devices, because in a way it's a network of machine-machine interaction, something like that, right? And actually Holo is doing ratings like that. It's logging the bandwidth, online, offline time usage, so that when I go and host my application, different quality of devices will have different prices or whatever. Would that be an example?
Yeah. Go ahead, Razan. Do you want to?
think yes, but not exactly. I don't know.
Yeah,
Okay.
I think can I just chime in here? So I think again to what you're saying, like we talk about the whole host port. So it depends on what you're hosting. If I assume this is something, if a host is not very reliable, I don't know, like we have a way to find out that it's supposed to be hosting something, but it's just not as reliable as what we can expect. We expect whatever the criteria is, storage wise, availability wise, access wise, then that's that. And I guess the peers could be like kind of querying pinging, and they can say, okay, this guy, a lot of times I ping him, he doesn't have what I needed, right? It's almost like IPF. So you have to realize, you say you're storing my file. Are you really storing my file? If I ask for you, are you going to be able to get it back to me quickly enough? Like 95% of the time, it's 100% of the time. And then, based on each peer's pinging, they probably have different scoring depending on what kind of response they get. Right? So I could think of that even in terms of like autonomous vehicles. If you're feeding in traffic information based on the sensor or whatever, if the data you're feeding in is not reliable comparing to others, I guess we have to have a way, I guess, in different contexts to define, to be able to assess, is it good quality service or not very good quality service? And then there are different ways of attacking, I guess, that can swooping.
Yeah. Perfect. I think I'm getting it. The last suggestion or question also is that is that something that membranes can help solve, in the sense that maybe if in other technologies you have to rate devices because you don't totally trust them, maybe with Holochain you can trust more because you have a strong membrane around your application? Could that be? I don't know. And if you say to me, it's okay. The question may not be appropriate, but it seems to me that with membranes you could be able to trust a little more those devices already in the network. Membranes in the sense who is allowed and who is not allowed in the network. The network is not totally open, or maybe it is.
Can I clarify the question in that case? It means just by being part of a DHD, if there is no warrant against you, you already have the trust. Is that the question? Yeah.
Yeah, the question is if that can help solve the trust issue we have here. Yeah. If the membranes can help solve the trust issue.
Mm-hmm. It
Right.
could?
Okay.
Yeah, Razan, before continue, would you please stop sharing that we can see each other if you don't? Okay, thank you. Please. Go ahead.
So I think, membrane determines if you can join, right? But I think in the case of IoT, it's one aspect of IoT is constantly evaluating. So then we talk about so then you kind of have to have a constant validation to see, that kind of pull in sort of warrants as well. Maybe, one of the attacks might be like you are a good citizen when you join. And then sometimes you provide good service and then you have some malicious acts. The dynamic mechanism of it, it's a constant evaluation of that. It's almost like, your reputation can go up and down and up and down.
Yes,
Razan, do you want to add to that?
In membranes, they will be all in the same level of trust if we use membrane. But using the trust level, we can differentiate between agents.
Right. Okay.
Anastasia?
Yeah, I just have an example that I'm not sure fits what we're discussing here, and I want to check. So when we're talking about trust in the system between different machines, for example, let's say I have a thermostat in my house and I have two temperature sensors, one in the kitchen next to something that I used to cook, and other one in the living room. So the temperature sensor in the kitchen can show an increased temperature temporarily when I'm cooking something, but it wouldn't mean that I need to increase my thermostat temperature for the entire house. So in this example, I would have two devices, both in the same DHT, so they have the same membrane, but one should be less trustworthy than the other one, because the temperature in the living room would be more stable and therefore can be more useful to determine if I need to increase temperature in the house. So is it actually applicable here?
Yeah, yes, exactly.
Cool, thank you.
So, guys, right now, I would like to shift the topic to you, not question. It means, what is your question? Because let me shift in that way. We know that the topic started from a reason as a solution for hospital, user devices, patient, and doctor. It was totally clear and obvious solution project application. Right now, you open a fantastic topic as a machine to machine that definitely we are going to support that. But the solution gets bigger, actually. It means you are in front of the bigger challenges. So right now, please change the gears to what you need. Are you going to continue both topic? It means, do you have any roadmap that you are going to create solution? It means how it's connected to the start point. First, are you going to select one of them and continue, or your aim is to continue both? And how we can support you and help you? What is your question? What is your question about the design, implementation, and if you need help?
Yes, for now, I will start it with the machine to machine. But we can discuss here in the Hackalong how the both of the system. So in case of using the capability or persona or profile, how can this application will be implemented in the IoT?
And so why you started from machine to machine?
Because I already start with this scenario.
Mm-hmm.
And I think in the implementation, it will be more simple because we have one network, one DHT that's managed the IoT. It's different than the social that have.
How it can help the original solution for hospital? Jim, I got you. I got you. How it's gonna be integrated with the hospital solution? It means in the hospital solution, it was totally clear that what we are going to design. I'm not telling it is good or bad. I'm trying to find the position in my mind. It means you are still on the solution for hospital topic, yeah? It means patient, hospital, community of the patient, and IoT devices, or you expand it. Make it clear for us that how we can help.
I think these are, both of them are different and separate. So there is no expansion, but just decide from where to start.
Yeah, can I, sorry, go ahead, Razan, finish first.
Yeah, you can. Yeah, Lily, continue.
Okay, so yeah, I think in the scope of the use case of hospital, patient, and doctor, if we look at the scenario, like what we're talking about, like we're talking about the patient rating, but then if we start looking at the patient's device, you know, like we talk about patient's device, there are some devices, I'm assuming the lighter, more resource constrained devices, they are tracking all the measurement that in that DHT, and then, you know, like that, some of those devices will send a direct message to the agent that cross both DNAs, like the patient device DNA and the patient data DNA, DHT, right? In this scenario, it's still patient, doctor, hospital network, but then you also actually have both machine to machine and social interactions there, because you're still talking about multiple devices, right? And I think one of the things that we talk about is that I need to get a better understanding myself too, is that among the IoT device DHT, if we just we're talking about trust, building trust network within just the IoT device DHT, and like what, in that particular scenario, how do we determine the trust? How do we do the rating? Is the rating, okay, so we can kind of decompose the rating process into one, collecting the data, aggregating the data, obtaining the data, and then calculating using the algorithms, right? So assuming the data are not going to be aggregated within the IoT itself, there's first of all, there's a direct IoT to IoT, machine to machine interaction there. And when each device report its rating for other device, it has to be able to reliably connect the rating to the device ID. So that's one factor. We've got to have the unique device ID that connect. Then if assuming all the data, all the rating information from each device is connected, bridged over to the other DHT, the data DHT, and you know, then it gets calculated either by some other system that does an algorithm that you can plug in to calculate that, then maybe that somehow get fed into the same patient data DHT or some other DHT that will give the rating information to be shared. So that machine to machine is still valid within this particular use case. And also in this use case, we also have the patient to doctor rating that we discussed last time. So that's what we started discussing. Rosa and I were discussing, like, how do we, you know, like there are different scopes we can kind of approach this. And, you know, to Hidayah, to what you're saying about the roadmap, what do we want to focus on first, right? So, yeah.
Mm-hmm. Let's hear Jim. If there is any topic, I would like to mention a point. Jim?
I just remember from last week, Guillaume made a point like that, and I think you were making the point too, Hidayah, that if we put multiple IoTs all on the same DHT, then now they have to be holding each other's data. And they're not really set up as big units. They're like, I got this on my watch. So I think it makes a lot more sense to use the right-hand diagram that was labeled today. It was labeled social, but I think it's more like there's a hub DHT. It doesn't have to be a human. That hub could itself be a robot that interacts with other robots, but the IoT's got to connect to some hub somewhere that has a little bit more power and a little bit more memory where the data would actually be stored. So then the IoTs would just be sending messages and not actually trying to store the store a DHT locally. Yeah, Guillaume, didn't you bring this up last week? Wasn't that you?
Yeah, actually, can I add to it?
Sure.
I think Rosen's diagram actually shows that what Guillaume suggested. So if you remember, actually, the diagram was showing there's a left DHT and then a right DHT, and then there's a fog node in between, fog bridge in between. So the left one is actually just devices, even though they are in the same DHT, they're not doing the gossiping, they're not doing the DHT sort of validation storage, sharding responsibility. They're just sending direct messages to this agent that cross both DNAs. And then all the data sorry, I call this the patient data DHT, which is on the right, that has more resource-rich devices that can actually do the gossiping, that can actually do the sharded storage. So, so the devices on the left side, the IoT, just a device DHT, I guess, that's what I call it.
Rezan, would you please share again that Lily can explain easily?
Sorry.
So, as also, it was my point. I would like to resonate the Jim. So, Guillaume also wanted to talk here exactly. And also, you can give permission to Lily if Lily can want to kill it. And Lily, the topic that Jim also mentioned, it was the same with me. I was thinking the pattern, the topic, title of topic. If IoT, all of them are going to be inside one DNA, since anybody inside the DNA is supposed to participate the DHT, it means we would have a memory issue. So then we offer that it is better to split it up, IoT devices in a different DHT, and they send a message to the another one as a data warehouse, as a place that accumulate the data. It was the whole topic.
Right,
So,
that's
I
right.
think she was just saying that even on the left here, she's assuming that even though that these IoTs are all in the same DNA, they're not storing anything on the DHT. They're only doing messaging.
How it is possible when they are in the same DHT, when you are in the same DHT, you are participating data. I'm gonna quiet Guillaume if you would like also, you have a question.
Yes. Oh, go ahead, Lily. Sorry.
No. Sorry. So I think a lot of these messages I just like this DM on the left side. That's a direct message into an agent. That this green box that's labeled FOC conductor. That's a agent that cross both DHTs. So this might be a laptop, for example, which the different devices, when they have the data, they just send a direct message over to this guy, the FOC, this FOC node, which commits into the DHT on the right side. And so, yes, that's true. If all the devices on the left side have the DHT, they would, they have to do the sharding, gossiping. Gossip, they still have to do, well, but the thing is that if most of the data you're not committing to the DHT, if your data just in your own source chain, right? And all the data just being sent directly over to this FOC node to be pushed in, commit into the DHT on the right side, you won't have that much data in the DHT at all on the left side. Okay, sorry.
Yeah, no, this discussion is really important, and it's so awesome. So two things here. One, maybe first, what you just said about private data on the source chain. So that's right, but the problem is that the headers are always public. So you will have one header each time that anything is committed to the DHT, and in the case of IoT devices, that can be very, very big. So that's one thing to take into consideration. And headers like in terms of payload, one header is equal to one entry. Like it's the same payload into the DHT. And then I wanted to mention another solution that actually think people from RedGrid are investigating, which is using Holohost or some hosting, like maybe not the Holohosting network, but some clone of it, to actually host the running application in a Holoport, and your IoT device acts like a Holo browser. It's not a browser, but it only contains the private keys. You don't even do any source chain or any conductor there. That IoT device connects to the Holoport. That could also be a possible solution. I hadn't thought about that, and I thought that was clever.
Yeah, that's It's a very interesting idea. Yeah.
I think so.
Now, Sadia, please.
Yeah, I have a question. So moving the main functionalities for maintaining DHT from the IoT devices to some more energy and memory capable machine, it doesn't actually resolve the problem of trust between the devices, right? So we still have to validate if a device that we receive metrics from. Okay, cool.
I think keeping them separate maybe it seems like it might scale better, and there's also the issue of data privacy, right? You've got health data, so something has to be the gateway for that health data. So I don't know that I would want to put it out on a hollow port, like all my blood pressure readings for the day. But I could keep it, and I don't even know if I wanted to, any kind of, I don't know if my blood pressure device really needs to be able to talk to my watch, but if they all talk to my laptop, that seems pretty sufficient to me. And then the laptop can figure out which devices are allowed, which devices have the right amount of trust, and can act as a gateway then to see whether it can send that data out to the doctor or whoever, right?
Yeah. Sorry, Razan, go ahead.
I think in the example of patient and doctor, the patient will have the control of his devices. So it's not only will be the machine to machine. So we can consider it as a social IoT. So as a patient, he can decide which device you want to communicate.
Jakub.
Yeah, and perhaps clarifying question or perhaps a comment, because for me it's still a bit unclear whether actually framing it as an issue of trust is the useful way, or another framing. My question would be, what is actually the potential, what kinds of uncertainties are we trying to solve, and what kind of costs or trade-offs are there, and what are we optimizing for? Because without those things, it seems to me it can be easy to get lost in questions of trust or reliability. But if we don't have the benchmarks of what are we actually, what kinds of uncertainties are we optimizing for? Not dying, or for just like small costs over a long time, or is it for like, so it seems to me that this might be, at least for me, it might help really.
The same here. It was the same, the first question also I asked somehow the same, that why do you need machine to machine in your first solution? In a hospital solution, I understand. But right now, I don't understand what machine to machine can help you, and for what question we are answering.
Yes, in case of the driverless car, so we have the community of a group of cars. So if there is a car that faced the accident in the road and sends this message to peer in the same community, so according to the trust of this car, we can accept this message or not, something like that.
So I don't think so. It is a good solution to think. I can understand machine to machine like a payment in the gas station, something like that. But I don't know. Two cars supposed to find each other via DHT to do not accident. It is just actually they are finding each other via peer-to-peer radar. So it is exactly the point that we need to think about where we are going to use it. It means we cannot say, okay, just machine to machine, two cars do not go to accident. It is not a good solution for a machine to machine, because if two machines are going to have a self-drive, It means what is the bigger topic? It is a self-drive auto. So self-drive auto, it is not, they are not going to use Holochain. So it means the question maybe cannot be valid. You know what do I mean? For example, we can discuss in a red grid as an energy, or we can discuss. I totally resonate, Jakub, that it is totally abstract, and that's why it's gonna be endless discussion. And I don't want to go for the first endless discussion and just personal opinion, and that's why still I would like to go back to your hospital. Is there any relation to hospital? Would you like to continue the hospital? I personally, I'm looking forward a way. How can I help? What is the question?
No, I think it makes sense. Like, you know, like what, I mean, this is what's the discussion too. Like they are, if we stay with abstract generic model, there are a lot of different use cases, and some use cases are not appropriate for Holochain. Some are, right? So I think, you know, like yeah. So I think, you know, the exercise we went through early on is that this is really broad, right? When we talk about this is really broad. So what is that we really want to focus on? You know, we could, yes, the hospital, the use case we discussed last time, it's definitely a lot better defined, and we have much more clarity on that using that. So I mean, that's definitely, you know, that's one option we can take. So I think Razan, so I mean, I think, you know, like definitely not here, but you know, we should take it offline to see, Razan, if that's a route that you want to take, or would you, if you still want to do the machine-to-machine trust, then I think maybe we scope it down a little bit and then think about within that, what can Holochain help with, right? And then we can focus in on maybe more fine-grained use cases in that scenario. What do you think?
Razan, it's just
Yeah.
it was a question from your side. I think Lily
Yeah.
asked that. Also, I suggest, highly suggest, or highly recommend that when there are two big topics, the machine to machine, machine to human, and somehow human to human is not IoT actually, but in the solution of machine to human plus machine to human and human to human as a big solution. If you are talking about this one, machine to human, because you have already use case like a hospital, it is clear to all of us, and that's why we could continue and we could reach the first level of architect and design. But about the machine to machine, it seems it is totally abstract. There are two options. You can select the first one. We are not going to remove the second one. We are telling go step by step. You can either select the machine to human, hospital solution. Let's continue for the next step. Let's continue for the next step. Or you can select the machine to machine and go for the, as Jakub mentioned, and also Nastasia, when Nastasia asked the example of the heating on her example actually, it means go for the better example that Holochain is supposed to answer that question. And then we can say, okay, in that solution, we can help. It will think to find the solution.
As a hello host that can support that. Can we continue in this example?
Guillaume, what do you think? Holohost, the solution of Holohost, or okay, Guillaume, go.
Yeah, that I think that's orthogonal to the trust discussion. I think that's where do we host the data and so on, and the other parallel discussion. It's not. I don't think this solves the trust issue. I think. I don't know. Maybe I don't think it does.
I do. I'm seeing that, like, I think what Lily said and what Hidayat said. is that we've got two separate, and everybody, I think we got two separate models. Jacob was saying this, that if we push forward on the hospital model, then we know what we're talking about. But the machine to machine, when we've talked about that, we start talking about autonomous cars. So autonomous cars is a totally different thing. And we should take a step back and develop if that's what we want to talk about, then we should talk about what are the requirements of that. And that's kind of different than what's going on with the patient. And maybe in car to car, maybe Holo makes sense. And in the patient hospital thing, you can't really keep your patient data on a Holo, so that because of privacy concerns. So I think we gotta pick one of these to push it forward is what or we can pick them in succession, but it's hard to talk about both of them at the same time.
And also, Razan, or Lily both, look, it doesn't mean shut it down. And I'm thinking to go, look, hospital, human IoT is clear. Maybe you can say, we are going to install IoT application on a laptop. It's going to connect to the blood pressure, blood sugar in a hospital. For the people that totally in a ICU, it means it automatically connects to some devices and asks, would you please execute blood pressure at 4 a.m.? Would you please, because the people, it is on the bed in the ICU. In that case, machine to machine makes sense. It means there is an application in the nurse station. It's supposed to program and send a message to the unconscious patient and sending a signal to the blood pressure that, hey, it is 4 a.m. after 6 hours, go for a 1 blood pressure, go for the 1 blood sugar, go for this one. So, and then we can know what we are going to do. It is exactly machine to machine. Then we can go to the better solution. I mean, we can think about the reality than go to the things that it is not the case for us. Got the point? It means if you would like to combine, there is a possibility, but please go for the things that we can fix it. We can think about the solution.
I had a question. What is the goal of this discussion? Are we discussing on the IoT tangent, and that's what we are trying to explore, or are we trying to help Razan in achieving her assignment? What is the goal? Can we clarify that?
I think the main goal is try to. So go ahead, Lily. Go ahead.
No, that's okay. You can go ahead, and I can go after you.
It is IoT. Go. IoT. Lily and Razan, answer, please.
Okay, Razan, go.
I think both of the scenario will help me in the thesis. Since my idea is an abstract idea, so I can choose which one. But the important thing is to just put the trust with IoT machine to machine, so we can choose any scenario or any use case.
So I would suggest, because I'm also part of the IoT with Lily and Razan, we go for the meeting and we would clear it up inside our private meeting. I think for the virtual hackalong, it is enough. So I think, yeah.
Yeah.
I can suggest that for today we can say it is enough about the IoT, but if you think we can continue.
No, I think so. Maybe a topic that we are carrying along for some sessions, and it would be valuable for IoT as well, but it's much broad, is we could maybe touch on capability tokens and how do they work, if that's okay.
If you are ready to explain, please. Up to you.
Is that Lillian and Razan? How do you feel about that?
Yes.
I love to.
Yeah.
Yes, I love to hear
Yeah.
about
Let's
capabilities.
go.
Okay, and just to be clear, this is not only for IoT, but it's a basic Holochain primitive that I think everyone should be aware of. So I think it's important that we explain it. Okay, all right. Let me go into the sharing of screen. Create new diagram. Let's go. Okay. So, okay, wait. This is I am the master of capability tokens. This is I don't know what the token that's hot, right? Where's everyone in capability tokens? I know everything. Capability tokens, I don't know anything. Okay, kind of a mix to low. Okay, yeah, that's good. So for a basic introduction, capabilities token are a way for me to let you call functions in my node. That's basic gist of it. It's basically, hey, I'm letting you this here have the token from which I let you call a function in my application. That's the goal, basically. Okay, so let's see. We have here a conductor. So this is Alice's conductor. Alice's conductor, and here is Bob. Bob's conductor. Okay, and let's say that they have the same DNA installed, and the DNA is, I don't know, for example, a DNA that only lets you see a content if you subscribe to a channel or whatever. Like imagine a medium like a blog post with subscription-based payment. So only if you have paid, you can see the content, something like that. I'm using this because Hedayat and Philip and Tom were doing this at the Barcelona Hackathon some time ago, and I think it was a very, very useful use case to think about the capabilities token. Okay, so in this case, we have here the subscription DNA, right? And both Bob and Alice need to have that same subscription DNA. Ooh, I cannot, okay, doesn't matter. So I'm going to expand this a little bit and say this subscription DNA has a function that we are going to call get private post content, right? And let's say that Alice is the one writing the post, okay? So Alice writes the post and then it publishes the post to the private source chain, for example. And then Bob is the one that wants to read the post. Am I making sense with the example? Is the example useful? I can change of example, but I think this example is good.
Fantastic, go ahead, yeah.
Okay, perfect. So in essence, we have the content here in the private source chain of Alice's conductor. So Bob cannot read it, right? As it should be. If nothing happens, public agents won't be able to read this. But Alice exposes a function that says get private post content, okay? And Alice says, okay, whoever has the capability token to call this function, my node will receive those calls and will return the content. So the way that goes is, let's say that we have here the source chain. Okay, so subscription DNA, functions, some functions, and we have source chain. So in the source chain of Alice, this is getting a little, it's okay. In the source chain of Alice, we have the block post, private blog post, something like that. And then here, Alice can do some special function that says grant Bob permission. So imagine Bob pays like fiat, it doesn't even have to be Holochain currency. Bob pays fiat to Alice or whatever. And then Alice from the UI says, okay, grant Bob permission to see my blog post, okay? So it would execute this function. What would this function do? First of all, it would create a capability token grant in the source chain of Alice. And this capability token grant is recording, okay, I'm giving Bob the capability of calling this function. And here we are recording which functions Bob will be able to call, all right? And then with a direct message, Alice is sending to Bob the capability token claim, which is like the capability token itself. So here, oops, Bob would have in the source chain, Alice sends the direct message, and here Bob will store the capability token claim. And the capability token claim is basically a very small entry that says, Alice has granted me permission. Here is the grant that Alice used, so the hash of the grant. Anytime I want to call get private post content, I can if I provide this capability token claim. So that's the basic procedure. And then we will go to revoking capabilities token, but I want to check in now. How is this sounding to everyone? Okay, good. Any questions so far?
So the post data, blog post data, is not actually stored on the DHT. It's only stored local.
Yeah, yeah.
And a message has to be sent, and then the data can be sent back. So
exactly.
In order for Bob to read this, Alice will have to be logged in.
Yeah, Alice will have to be online. Yeah. And this is the same for any capability token. Capability tokens only work when the receiver of the call is online, because otherwise, yeah, okay, I can let you call whatever you want, but if I'm not online, you won't be able to call me, right? So the receiver agent has always to be online. That's the case in every use case of capability tokens.
Yeah, so actually this is interesting because when we're talking about this capability grant, last time we were talking about if a patient is disabled, those might have to go to the family members. So this was another thing that came into thinking. But you know, I don't want to discuss it now, but there might be another pattern we need to create to serve situations like that, right?
Interesting, yeah.
So this is a way, one thing I see here, this is a way that we know that we're getting, in this case, you know that you're getting the latest data of the blog post.
Yeah.
Whereas if it's just out, if you're just pulling it off the DHT, you because of eventual updates, you might not have the latest one once you get it, but you can get it at any time. But in this case, Alice has to be on board. But if you do get the data, you're guaranteed to get the latest data.
Exactly. That's a clear trade-off. And it's like capabilities tokens are one of the last primitives we all need to learn before having a clear picture of everything we have in Holochain. So there are use cases in which it's better to go the capability token route better than do it via DHT. But
does the you know how with a normal Holochain, if you go to get something but it's been updated, Holo follows it along for you automatically so you can get the latest one?
Yeah.
Can you do that too? So I can ask, Bob can ask for Alice, please get me this blog post, but he had the older one. Will it actually, can it give him back the latest one?
It depends. So this function can do whatever it wants, right? So you can say iterate over the source chain to find the latest one. Yeah, that's perfectly fine. But if that post can be updated by another agent on the DHT as well, you won't have it in this source chain, right? It's going to be out there. So in this case, this is a bad pattern. You see what I'm saying? You have to be careful when to use this as opposed to DHT for getting the latest version, because it assumes that only you can get it. I cannot date it, sorry.
Sure, but it's on Alice's source chain, so I'm assuming only Alice can update it.
Yeah.
But if Bob asks for it, he might ask for an earlier one, but I want to make sure he gets the latest one, so I could write the function that way.
Yeah.
It seems like a way that I could hold in. Well, it's very useful. Thank you.
Perfect.
So one question to help the whole topic: should we say token grant in a chain, or the signature is enough? Capability token grant. There is something extra we need to save, or we just issue the token claim?
Yeah, that's a good question. And I think you have the grant because you can revoke it. And because the grant here, we are storing the signature, obviously. The granted agent, so who I'm giving this token grant to, the functions that agent will be able to call. So all of this information is necessary in order to see if an incoming request is valid or not, right?
Yes.
Yeah.
Gotcha. Thank you.
Yeah. Do you think there's something else to add here?
So signature coming, saving. Yeah, I really would like to hear anybody understand till now how the things are working. Otherwise, please continue.
Okay, sounds good. Perfect. So if you think, interrupt me whenever you feel like. If you think about it, the owner or the authority for the capability token grant is Alice. I have granted access to Bob, but the grant is on Alice's conductor. So at any time, Alice can say, I'm going to revoke the capability token grant revocation, something like that. I don't know the exact name, but something like that. And let's say that this grant has a hash of 45. So this capability token grant will say, this capability token grant revocation will say which capability token grant it's revoking. And this means that whenever Bob comes with his claim and says, hey, you granted me access, and Alice says, yeah, I granted you, but now I revoked you. So Alice is in control at all times of the permission she sets up for other people to call her. At any point in time, she can decide, no, I'm going to revoke that access to that guy. No, I'm changing the conditions of our agreement, because it's Bob, it's Alice's node that lets others call it. So this is a very different paradigm than validation rules, for example. This is the node that's granting access has all the control in the world. Because it's like, I don't know, you having your room and only letting people in that you want. And you can at all times say, no, I don't want you anymore. This is very different than validation rules in that aspect. Is that ringing a bell for people? This is all there is. This is basically Are there any questions?
Yeah, I would like to add a question for a better solution, especially Lily and Razan. It's question can maybe somehow goes also to IoT. So, is there any way that I can issue a capability from my this DNA for other DNA? It means as a bridging, anybody without being inside the current DNA just call me and read data.
Yes, but it's a little different. So what you do actually, so Hidayat is saying, okay, what if we have another DNA, and I'm going to make it more slow, more small. So another DNA, and
Blog, for example, it's going to be
right,
blog or YouTube channel or something.
yeah, okay. I think you cannot grant, and I have to verify that, but I'm pretty certain of it. You cannot grant capabilities for other DNAs because actually Bob is not even on this DNA, so it doesn't make much sense. What you can do is this get private post content. Inside this code, it will have a bridge from this DNA. That didn't. Okay. It's okay. So when this function is called, Alice will bridge from this function, call the block DNA function, whatever, and here Alice is calling herself, so she can call her or DNAs whatever she likes, and then returning the content here and returning the content. So yes, you can, but it's an extra step of I receive the call, I validate capability token, and now I bridge to my other application. Thank you for the question, Hedayat. I think, yeah, this was useful. Yeah, go ahead, Tats.
Is there any limit on what function you can call on the other side, or you can just pretty much grant any function to the other agent by the capability token?
Yeah, right now things like validate agent or receive or things like that don't make much sense. So you can call some functions, not hard coded. I don't know how to say it, callbacks from Holochain. Not validate agent or receive. You cannot call that because
I see. Okay. So because I was thinking of one way to use it to solve one of our problems, because right now Holochain doesn't have a way to encrypt and decrypt your entries with another agent source public key. So we were planning to incorporate another. We were planning to incorporate Rust crypto WASM. But then, if we can just use the capability token grant to call, say, encrypt message on the, for example, if I'm Bob and I call that on Alice source on Alice conductor and call that and encrypt the entry before I send it to her or commit it to the DHT, then that's like me encrypting entries with another person's public key, right? So that way so yeah, I guess my question would be, do you think that's possible? Is that something that can be done?
Like, okay, you're saying I stored encrypted entry.
Yeah.
So for example, Alice wants to encrypt something with Bob's public key, something like that.
Yes.
And then it encrypts it outside Holochain or with your library, and then it stores it on Bob's source chain? Or
no,
where?
it commits it to the DHT.
Uh-huh.
So that Bob can retrieve it.
Yeah.
But then he can be the only one who can read it because he's the only one who has the key to decrypt it.
Yeah.
Right? So that's very useful for things like asynchronous private messaging on a network where there's other users, agents that can read data, right? So this can be one possible solution if ever we could not make separate DHTs for separate chat rooms, at least we can encrypt messages, and we don't have to use third-party libraries. We can just call so basically there would be a function like encrypt message, and then we can just pass the string itself there, and then it's just gonna return. So my question is, can you do something like, okay, I'm gonna call encrypt message on, if I'm Alice, I'm gonna call on Bob, encrypt message, and then the returned encrypted data, like, can I do stuff with that? Like, can I call another function on my conductor to submit that to the data?
Yeah. I see what you're saying. Yeah. So you're saying you send that direct message to Bob and asking him to encrypt it, and then Bob returns it encrypted, and then you can post it. Okay, but you absolutely can do that. But at that point, Bob already has noticed the message and has its contents.
Okay, so then my question would be, for example, I'm going to be calling a zone function on other agent's conductor, right?
Yeah.
And say that has a parameter. How is that parameter passed to Bob?
Okay, like right now?
I mean, okay, wait, am I making sense? Or is it something like, do I get access to Bob's key to encrypt the message, and like all of that will be done in my conductor or in Bob's conductor?
No, in Bob's conductor.
So there has to be a way for me to pass the entry unencrypted, obviously, to him, right?
Exactly.
So is that gonna be done over SIM2H in a way? Like,
right
is that
now,
a send? Does it work like send receive?
Yeah, it's a send receive basically. So just to clarify, because this is a little confusing. Right now, you cannot call directly other functions on other Holochain conductors. You have to do send receive, send direct message, pass the capability token, and then that other conductor does have to call itself. On the next Holochain RSM version, you're going to be able to do remote call directly. So it will be much more convenient, and then pass parameters or whatever. I didn't want to confuse people with this, but it's just the state of affairs. It's a little weird right now.
Yeah, that's true. Okay, I see. Okay, then there's a loophole.
Yeah, it seems a little bit weird to if you have to send the unencrypted message over to Bob in order for him to encrypt it, come back to you so you can post it encrypted so that he can read it. It sounded good initially, but that's a little bit. It's like, I'll send you my message in email, then you can encrypt it and send it back to me, and then I'll send it to you encrypted.
Yeah. Okay. Makes sense. Okay. Thank you. That made it clear for me.
So, guys, I would like to resonate Nastasia about if we can postpone a little, because we are already more than 2 hours in the meeting. So also I'm totally tired. So, but thank you again. I think everybody got their first interaction about how the capability is working. Definitely. I really would like to see Tats again, because honestly, right now, my brain is not working. I'm at the end of the day. I didn't follow you. The last conversation, I didn't follow. I really would like to hear you back again. So if there is no basic, because we can refer to this session as a basic knowledge of capability, I will try to find a solution from a Barcelona. It is in a GitHub, and share with you in the Discord. So you can see how the implementation is working. If there is no more question, we can wrap it up today. And next week, definitely, if there is a question, we can continue capability talk.
Awesome.
So, Gian, would you like to add something else?
No, that's great. Yeah, sorry to start such a big topic.
Thank you. It is fantastic, and it would be also brilliant that we split it up. That people can go think about that, observe the fundamental, and we can continue. Gian, thank you. It was fantastic. So Kiki, we started at 6, not 5.
No, right, but she's in the UK, I think.
Okay. So generally we start Central European at 6, and we would like always to finish at 1.5 hours, but we cannot do that. Let's see. So thank you guys again. I love you. I love you to see you here, and see you next week.
Thank you.
Thank you. Great to see
Bye-bye.
everyone.
Bye.
Take care. Bye.
Bye, guys.
Bye.